So now we will discuss on matrix interface with the LPC2148. So it's like 4x4 matrix, okay? 4 cross 4 matrix keypad. So coming to a single key, the architecture of single key, it's basically you will have one resistor connected to 5 volts. So this is actually a current limiting resistor. Okay? So I mean, actually, like as soon as like if you connect directly to the ground, right, what will happen? You will feel the short circuit, right? So that is where they have this as a current limiting resistor. It can be of any low value, and you will have other end connected to ground, and there is a gap. So in this gap, so we are fitting a key. Okay, as soon as you press this key, right, as soon as you press this key, what is going to happen? So this end is going to ground, right? So whenever the switch is not pressed, it is open, so you are going to read plus 5 volt at this point, the port line. Okay, port line, that is digital 1 you will read, right? So digital 1 you are going. So as soon as the switch is pressed, so this 5 volt, it is going to be grounded, right? This is going to be grounded. So always whenever you connect, like either it can be higher voltage, any higher voltage, as soon as you connect that point to ground, so it is going to be 0 volt. So then you will read 0 in the digital value, right? So this
Yes,
is
sir.
how actually, this is the basic idea behind your keypad. I mean, you might have seen like all the real-time applications like washing machine or microwave oven, fridge. Everything will be having the keypad interface, the user interface. Right? So when I say 4x4, it is actually 16 such pins, right? 16 pins, 16 switches. But I mean, if I use this kind of logic for every pin, then I need 16 such pins in the microcontroller, right? So 16 such pins I required in the microcontroller. That is like little, uh, even to scan me also, like it is complex. Also, it consumes lot of pins, unnecessarily it consumes lot of pins. So yesterday also I was working one of the interface where we convert everything to a single analog value. So all 4x4 matrix output, I convert into single line as an analog value. So this is the trending one. So you can just read the analog value. So you know that like if you press first key, like you will get one analog value with the various ranges. So based on that range of analog value, using A to D converter, I read switch values. But in terms of the LPC2148, if it is because Arduino, you have like various libraries and you can just use it. But in LPC2148, today's discussion, the scope of our discussion using 8 pins. Okay? Instead of 16 pins, we will use 8 pins for scan. 8 pins. That is a parallel interface. So on this end also we can discuss like how to use the analog interface and interface to the microcontroller. Let me share the screenshot of our interface diagram. So here, if you see, we have 4 rows and 4 columns, right? And each rows, like we have connected four keys, and like each columns also we have connected 4 keys. So basically, we have to develop a scanning algorithm which can actually scan these like rows and columns. So, it's a little tricky, but let me show you how we usually do it. So you can see So for instance, like if I press this,
So this is a keyboard experiment.
yes, keyboard.
Okay.
So for example, if I press this button, right? So here, if I connected 3.3 volt, so this pin is going to be 3.3 volt, right? So because I'm establishing the connection, right? So if I leave that as it is, I mean, if I don't press the keyboard, whatever the values are there in the node, that value I'm going to. So this is the basic concept. Like previously, I shown you one of the example, right? So you see here how that actually, like if I press this, it is going to be ground, else it is going to be 5 volts. So like basically, what we will be doing, we will be like scanning this each pins. I mean, we will generate various patterns, and based on that we will scan the values. So if you see here, like the rows are connected to p dot 16, 17, 18 and 19, and columns are connected to p1, port 1 of 19, 18, 17, 16. Okay, so for instance, now if I haven't connected, if I have not connected any pins, okay, uh, so you can see here all the lines, like here I'll be reading the values at E1. Okay, all the lines are connected to 3.3 volt, right? All the lines are connected to 3.3. So you will read 3.3, that is 1 1 1 1. Okay, so you can see there is nothing is connected. So this 3.3 directly it is going to be input for you, right? So 3.3 volt is nothing but high. So you will see that 1 1 1. So if all the pins are 1 1 1, so it means none of the pins are connected. No pins are connected. Now, for instance, if I press this button, okay, if I press this button, then what will happen? If I made this P0.16 as 0, if I drive this as 0, then what it is going to happen? My P1.9, I will read 0. The rest of the pins are high. This point, did you get it? If I press this button, this is connected to 0. I mean, so initially I will drive everything as 0. This is output, and I'll drive everything as 0. So if I press this button, so this 3.3 volt is going to be connected. So this is the initial one we discussed, right? As soon as you press it, so that line is going to be grounded. So here you will read 0. So it will become 0 1 1 1. This point is clear?
Yes, sir.
Yes. But there is one challenge here. I have pressed here, then I'll read 0 1 1 1. But if I press this button also, then also I'll read 0 1 1 only, right? If any of these rows buttons, if I press, any of these rows button, if I press, then I will read 0 1 1 only, right?
Yes, sir.
Right? So how to identify out of this row which button I have pressed? For that, we have to use scanning algorithm. So I'll not make everything as 0 0 0. What I'll do, initially, I will make 0 1 1 1. Only LSB 0. So if I had pressed this button as, if I had pressed this button, then I will get 0 1 1 1. So in this scan, if I had pressed any other button, since like these are 1, so you will not get 0 1 1. You will get 1 1 1. So in this scenario, right, whichever the button I have pressed, so first it will be 0 1 1 1. Then I will pass 1 0 1 1. Then I will pass 1 1 0 1. Last I will pass 1 1 0 0. So whichever the pin I have, like at the last I will press this F button, then only I'll get 0 1 1 1. So in this way, I can scan which particular button is pressed. Clear?
Got it, sir. Yeah.
Okay. So
Sir, and the keyboard experiment should be executed in tera terms, sir. Like. different software to display the output.
That is actually just to display the output, which button is pressed. So teraterm is not the requirement of this keyboard. So teraterm is basically, it is used for serial interface. So you will be printing something in your software, right? So when you connect to the teraterm, so you're going to get the result of printing just to see that which button is pressed. All right. Now,
Yes,
let me ask you one question. So you assume I have pressed 6. Okay, I have pressed button 6. Okay, can you explain me the sequence, how it will happen, the scanning, how the scanning will happen?
so the scanning will be linked to the pin 18.
Right, you're right. Scanning is linked to the pin 18, but the sequence initially to port 0, I will transmit 1, 1, 1, 0 initially. That is like P. This is this MSP corresponds to P1 dot P0 dot 19. This is corresponds to P0 dot 16. Okay, so this one I'll send. This is nothing but I will be sending E, right, in hexadecimal E. Then I will read at P1. What I will read at P1, if I send this 110, so what I will read at P1?
Sir, I didn't get your question.
So initially, so the scanning is first I have to send some sequence at this point, right? I have to send some sequence at this point. That is like first first I need to check any of these buttons are pressed. 1, 2, 3. Any of these buttons are pressed. For that, I have to send 1, 1, 1, 0. 0 corresponds to this P0 dot 16. This I will make it 0.
Got it, sir.
Okay, when I make that, what values you will read at P1, P8, P1 dot 19, P1 dot 18, P1 dot 17, and P1 dot 16?
So the values will be 0.
No, because here everything is connected to 3.3. You haven't pressed any of these buttons, right? 1, 2, 3. So everything will be still 1, 1, 1, 1. So you will read 1, 1, 1, 1. Because you haven't pressed anything on the 1, 2, 3. So if you get this value, that is nothing but F. So it means you haven't pressed anything on the row 1, row 0, correct? Then what I will do, I will change this value to 1, 1, 0, 1. I'll send this way. I'll make this P0 dot 17 as 0. Now you have pressed 6, right? So this is 0 now. But since you have pressed 0, so this pin will become 0, P1 dot 18. So that's where you will read at the P1 1, 0, 1, 1. Instead of F, you are going to read what? B, right? B in hexadecimal, correct?
Yes, sir.
That means you have pressed some button in, and you have to find the location of this 0. That location corresponds to 6, right? So that is the pin you have pressed. So again, it will scan whether anything is there here by passing 1, 0, 1, 1. So you will receive 1, 1, 1, 1. So again, if you pass 0, 1, 1, 1, so still you will receive here. This is how you scan. Hope it is clear to you.
Yes, sir, I got it now.
So there is a concept of switching debounce. In the sense, as soon as you press this, right? As soon as you press this, so there will be, since it's a mechanical switch, it won't be like continuous, continuity will not be there. So you will see some kind of glitches. That's where we have to give some delay between the reading. As soon as you press, right? So some delay you have to give. So that delay usually like it is 20 millisecond. So the delay what you give to stabilize this switch after you press, that we call it as switch debouncing. Switch debounce. Okay. As soon as you press, you'll see some noise in the switch, mechanical switch. That we call it as switching debounce.
So that's why we in the code we write it as delay underscore ms and the value.
Some delay will give
Like,
as soon as you scan it. Right?
yes, sir. So changing that, we get the output, the changing of the lights and everything. So the
That is
pattern.
different. Actually, that is basically you are referring to the delay of like how much, what is the frequency of glowing the LED and all. That is different. This is like just to avoid, right? So as soon as you press it, so you will see multiple values due to noise. You are the mechanical switch. So you can assume something like that. As soon as the pen drops to the ground, so there will be some bounce, right? And then it will stabilize, right?
Yes,
So in
sir.
order to stabilize that switch, mechanical switch, we give some delay. That we call it a switch debounce.
Got it, sir.
Let's discuss the program also.
Yes, sir.
Let me paste the code here. So here, first we define this LPC2148. Okay, I mean you can start explaining. So if there is any mistake, I'll correct. So can you just let me know what was
Yes,
the
sir. So shall I skip the starting, define, and
define also? If you tell me, it would be good because those has some meaning, right, in terms of column selection.
yes, sir. So what is the function plock used for?
P lock, that is actually for your UART. Okay.
Okay, sir. So first, it's like we define LED off, plock, LED on, and so since there are like 4 columns in the keyboard, like for connecting and everything, it's like we define column 0, which is also one greater less than 19. No, so that's one or I.
It's one basically. One left shift
Yes,
31.
sir. So I'm talking about the column 01.
Yeah, this is also one left shift by 9.
Okay, sir. Yeah, so we define column 0, column 1, and column 2 and 3. And later, sir, actually the void system init and void, our sir asked us to make it as comment line because we were not getting the output.
Okay, okay.
So and later we also type the void delay ms, because later in the code we have to type a value for the delay ms. And sir, I didn't get to know the function of UART.
Yeah. So here, right, this PLL lock is actually clock. PLL, I mean P lock we say, right? It's a PLL lock status. So it has to be like high. I mean, which means that like our PLL is locked, the clock is locked. Okay, P clock and the things like that we were discussing. P clock and P clock. It's related to that. And here, coming to this, like let me assume that. So this is just function definition, so it's not an issue. Here, uh, these are all function definition. For the time being, let's skip this. So uh, the lookup table, right? I am defining for my 16 characters, 16 switches like 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. And these are the switches of the 16 locations, right, of the matrix. So system init, anyway, actually here I am not using any system initialization. So see, this is basically right. It is for the switch setting of the PLL. Okay, if you see system init, right, what they are doing is basically you have to set the UART clock, right, the 9.8 bits per second. So this is actually system init. If you see here, come to this point. So initially, I have to set the clock speed of your overall program. That is done by your system init, right?
Yes, sir.
So if you see here, PLL con 01, what we are doing is we are enabling the PLL, okay? And 24 if we write, so we are configuring this PLL's multiplier and divider. And here we are feeding the configuration of the PLL, and we are waiting for whether PLL is locked. So PLL is nothing but, so we know that like our input clock, we will have some input clock, right? So we will, from the crystal, we will get some input clock. What we do, we feed to the PLL and we get some higher frequency clock. So internally, it takes some time to lock to the higher frequency. That we call it as PLL lock. So before lock, right, if the lock is 0, it means still it has not assigned or like aligned that place. So that's where like we have to wait till PLL lock is done. Then we have to jump back. Once the PLL is locked, right? So then we have to jump it. Then we have to initialize the UART. UART means, so you mentioned that in Teraterm, right? In Teraterm software, you were seeing some status of the pins, status of like which button you have pressed,
Yes, sir.
button status. So basically how it was done, you had one evaluation board, you had like hardware board where the keypad is connected, and that is connected to your laptop or PC. So in this Teraterm software was running, right? This is the interface. So you have to communicate this, right? So from board to PC to the Teraterm, you have to communicate. So the communication interface what we use is UART. Okay. For example, in your laptop, you connect the internet, right? So in internet, if you see like you kill your router, it might be coming through fiber interface or like through Ethernet interface, right? So then you modulate that and through Wi-Fi interfaces, so you get the data, right? Same way, the board has to communicate to the laptop. That is done through UART. UART stands for Universal Asynchronous Receiver and Transmitter. I think I had shared you that video also, right? With respect to 8051, I had recorded one video to the other student. I had shared you that
Yes,
video.
sir.
Please go through that also once, okay? So that will explain you the basics of UART. So that is where like I have to configure this. So see, both board and your laptop should know what is the speed at which I'm operating this UART. that is where the INIT function, it is going to initialize that UART frequency to some frequency. So if you see here, I am selecting TXT. So in the UART, right, we have two pins. One is TX pin, that is where I am actually transmitting the data transmission, and I have RX pin where I am receiving the data. Okay, that is TXT and RXT. Okay, so I am saying P0.0 is TXT, P0.1 is RXT. Okay, so in the UART, right, I will have first start bit, that is start. I'll send, because your laptop should know where I'm starting that UART, right? I'll have start bit and followed by 8 bit of data, and then I will have one parity bit. So this is the interface of your UART. Then stop bit. So this parity bit is optional. So it is parity is something like it checks the error, whether any error is there in your UART or not. So that whether you want to have the parity bit or not, whether you want to have the stop bit or not, so that you can configure by writing this U0 LCR register with TTP. Okay, and then you are also setting the clock rate, that is the data rate, to 115200 by setting this U0 DLM and U0 DLL values to 0 and 8. Okay, and this UL clear to 3. And finally, once everything is done, you will enable the transmission and receive. U0 FCR with 7. So it means you will start transmitting. As soon as you have the data, you will start the transmission. So this part, right, it is basically you are configuring the UART. Clear? That is the communication, what you see
Yes,
in the
sir.
Terra term, right? Okay.
So this part also, the down part, the void system in it, again, sir made us comment it.
That may be like a PLL, right? PLL by default is configured. So you might be using internal clocks. That's where like he just asked you to comment. So UART is required, but the PLL configuration, you can use the default configuration. Okay.
Yeah, sir. So for exam, part A and part B will be asked, no, sir? Like the code part.
Yes. So here, if you see that like P16 to 23, I'm setting it as output. Okay. And I will start the while loop. So in the while loop, what I'm doing, I'm making that row select as 0 and I set as F000. I mean, if you remember, uh, like we discussed that, like I'm basically sending that 1110 and then I'm reading the value. Right? So that is what they're doing. So they'll keep pushing the data. So if you see here, this ID0, right? So that is actually this part, right? P0 buttons. So they are controlling the P0 button by setting 0, 1, 1 and 1101 and 1110, and then they're reading. Actually, you can see that row select, I said they are doing this, and then they're actually reading the values. All right, you can see here. Call 0, that is actually they're reading the values. If like the value is 0, then basically what the call 0 is nothing but input, right? I1 pin, right? 19, 18, 17, 16. They're seeing whether that pin is 0. So they'll set that value. So if that is the case, they will set which button it is. So call select is 0. And here you can see they have written the truth table, right? So you can see the truth table. So if it is 0, 0, both are 0, then it is 0. 0, 1, then 1. 0, 2, 2. 0, 3, 3. So that way, actually, once they read the value, right, column select. So basically, this row select and column select, based on that, they are deciding which row we have chosen. So then you will actually passing that value, right? Whether it is like button 1 is pressed, button 2 is pressed. So that selection or like that driving is happening in the U0THR. U0THR is basically your terminal value, right? So that is actually threshold, your UART buffer. So that lookup table value, it is going to be sent to this U0THR and you will be seeing that value in the Terra tab, right? So if I take one example, like you have pressed any first button, right? First button. So in that case, like row select is 0. Row select is 0. This row, basically I'll set this row. Then what I will do, I will see if column 0 equals to 0, then column select is 0. In the sense, if this is 0, and if I read this as 0, column 0 as 0, right? Column 0 as 0, then it means which button I have pressed. First button I have pressed, right? That is what they are saying. If row
Yes,
select
sir.
is 0, column select is 0, then I am saying 0th button I have pressed. So then I'll break. So call 0, row 0. See, here LUT is accessing row select, column select, right? So row 0, column 0. Which value? This value, right? 0. So it will display 0. Same way, if I press this first button, so row 0, column 1 will be 0. So row 0, column 1, this will be 0. Column 1 will be 0, right? So then I'll break it. So then row 0, column 1 is 1, right? Column 1 is 1. So then which value it will select? See, row 0, column 1 is 1. So it will say button 1 is pressed. This way you have to keep scanning.
Got it.
Right? So hope these things you remember. So here we are setting the IO0 is actually direction is setting. We are setting the direction as output, right? And some other. So here IO0 clear. It means I'm clearing the bit. I'm setting it as 0. The 16th pin I am setting as 0. That is actually. And if you see IO set, that means I'm setting the corresponding bit to high, right? So here also the 17th bit I am clearing, and I was set like those bits I am making as F. That means high, right? This way actually we scan it, and you can see the delay. So some random delay we have given is like 10,000 count. So it's around 10 millisecond. I mean, again, like we have to calculate exactly using machine cycle and the values of how much time it takes for the for loop. That analysis we have to do, but some amount of delay it is going to be. Okay.
Yes, sir.